Hello, I'm Krista Spites, Hale Planetarium's director, and welcome to our virtual star party. So we are gonna, I'm here today with Heather Chamberlain. Say hi.
Hi, everyone.
Heather has her master's. She did her research on the moon, and she's with us from Alaska. So that's pretty cool that we can do virtual shows, bring in experts from far away. And then we also have with us Estefania. Estefania, say hi.
Hi guys. Unfortunately, I do not have a master's, but I love astronomy nonetheless.
And Estefania is one of our students in the department, the Physics, Geology, Engineering, Technology department here at NKU. And she's going to be talking about giving us some of the constellation lore and some cool space facts. She is going to be running Stellarium, which is the picture that you see on the screen. I'm here in Schneider Observatory on campus, and that's why I'm wearing the mask, because I am on NKU's campus. So Estefania and Heather will be doing most of the talking. Okay, Estefania, I'm going to turn it over to you.
Sure. Thank you so much, Professor Spites. I'm really happy to be here with all of you. I love that you guys are here now in this virtual star party with us, learning more about the never-ending universe and its vast greatness. I'm excited, and with that, let's go ahead and get started. So, like Professor Spites said, I am using a program called Stellarium. It is free to download, and I really encourage you guys to get it if have access to a computer. I think one of the benefits of Stellarium is do things like this and be virtual and social distance, but also if any of you watching are stargazers or amateur astronomers, you know how cold it can get at night and how, or hot and how uncomfortable it can be, and this is kind of a thing you can do at the comfort of your own home at any level and all ages. And with that being said, let's go ahead and dive in. So the first thing we're going to be doing is taking off the atmosphere. The atmosphere is a protective layer around our beautiful, beautiful blue planet. It protects us from lots of things, meteorites, incoming objects, sometimes falling satellites, the sun rays, specifically the UV rays, and it also keeps our planet nice and warm and also cold. Not too much of either, that's why it's habitable. Perfect spot, Goldilocks zone is what the astronomers call it. And you've kind of noticed that as I take off the atmosphere, you can see things a lot more clearly. For those of you who are maybe near Cincinnati or other large areas, there's a lot of light pollution. So with this, it's another perk that we can get around things like that. So currently we're facing southwest. If any of you are outside or can go outside, if you're curious enough, always just look southwest and you can kind of see the same thing that I'm seeing if you're in the same Cincinnati area. I went ahead and removed the ground, so that's the horizon, so now we can see a couple more extra deep space celestial objects. The first one I'm going to start with is Saturn. I am a very big, one of my all-time favorite movies was The Lord of the Rings. I don't know if any of you have watched that. Legolas is my favorite character of all time. But this planet has been nicknamed the Lord of the Rings. I love great puns, it's all good here. And for very obvious reasons, Saturn has some magnificent rings that can be viewed from telescopes. Back whenever early astronomers were first gaining access to being able to view these wonderful objects through a more magnified lens, the early telescope, they thought that it was a planet with big ears. And then as technology developed and as we became more complex with our technology, we realized that those were not spheres, but rather large rings made up of small bits of ice and rock. Just some quick, I guess, speed facts about Saturn. Saturn is the 6th planet from our sun. It is in our solar system, and it is the 2nd largest in our solar system. It's the largest is not too far away. They're neighbors. They're pretty close in vicinity. They're not close to us at all, but in intergalactic distances, they're pretty near each other. It is a gas giant with an average radius of about 9 times that of Earth. So I don't know how many of you have explored all of our planet. If you have, kudos to you. That's awesome. But ours is pretty big, so it's pretty hard to imagine how big Jupiter or Saturn can be. It is very large, but not everything about it is great and big. For example, Saturn's density is pretty low. It's only about 1/8 the average density of Earth. So to put into perspective, I guess, if you found a really, really, really big bathtub lying around somewhere in space that was big enough to hold the planet Saturn, it would float. It's so light and so not dense at all. Saturn is over 95 times more massive than a lot of the other planets.
And it's Stephania.
Yeah.
Actually have Saturn in the telescope. So why don't you zoom in on it on Stellarium, and I will show what it looks like in our telescope.
Sure.
All right. We get both views tonight.
All right, let's try to keep zooming and zooming. We're getting a shape.
There you go. You're starting to see the division in there.
I'm having to play a little game with Stellarium, I guess. Who can hold it? There it goes.
If you double click on Saturn, it centers it. And then you can just zoom in with the wheel. Stellarium is an interesting,
Yeah, there it is.
interesting program to learn. All right, are we ready to see in the telescope?
Yes. Let's compare Stellarium and the live view.
We've got some moons showing up here on Stellarium, so.
All right, there it is. Live from planet Earth.
You can see rings.
Yep.
You can. It doesn't just look like it has ears. You can see the rings divided out. Now we could talk about Saturn all day.
Yeah, it's my favorite.
But, there are other neat things to see. So I'm going to turn it back over to Stephania. Why don't you go back to Stellarium? I'll let you share your screen again.
Sure, I think that I think you stop
Pull
sharing.
Jupiter there, and we'll go to Jupiter and look at some of the moons, which we'll talk about.
All right, I'll go ahead and do that. I do need the, I think you have to stop screen sharing so I can screen share.
Cool. Stop share. Okay, go ahead and try it.
All right.
Good.
And here we are. Let's go ahead and go to the handy dandy Zoom and find our planet, Jupiter. Here we are. As I mentioned earlier, Jupiter is very, very big, and it is the largest planet in our solar system. One of Jupiter's main features is the big red spot. In the past, it could fit about 4.5 moons, but scientists are starting to see as they observe it with our new telescopes that it's actually becoming thinner. So it used to be one big oval, but now it's kind of becoming skinnier. It's still just as tall, if maybe not a little taller, but you can only fit about 1.5 Earths in it. We have these bands here. Just zoom in some more. These are known as cells. So each of these cells are a different color, and it's essentially wind blowing, but something to note is that each of these are going in a different direction. You can kind of see that. So here we have some arrows, and these are where the cells meet, but Jupiter has very, very strong winds, and these little spots are little tiny hurricanes or storms. And I think one of the most fantastic things about Jupiter is its large disarray of moons, and I'll let Heather tell you more about those.
Okay, well, Heather is talking. Can you zoom out a little bit so we can see the moons, Estefania? I'm going to share. So we've got okay, that's good. Oh, yeah. All right, I'm going to share the telescope view again, and we can see these, and I'll let Heather talk about the Galilean moons while we look through the telescope.
All right, the Galilean moons. Well, the famous ones are, what is it? I eat green cheese, I think is the listing of it. So we've got Io, Ganymede, Callisto, and oh, that's embarrassing. Io, Ganymede,
Europa.
and Europa.
Europa.
I always forget poor Europa with all of its famous studies. Okay, so we'll get to those fun studies in a minute, but Jupiter has in total 75 moons, or 79 moons, 53 being named, and the rest waiting for their names. So getting to the actual fun stuff would be Europa, which is the one that has an ice shell over it. And so a lot of people like to go study, or a lot of the planetary scientists like to go and study as much in depth as they can, trying to figure out what exactly the ice shell is composed of. And some people have posited the meaning of the ice shell as far as what it could possibly hold. Some have posed, is it good for life, or could we go live on it better than we could, say, a barren planet such as Mercury? Who knows? But it's one of those fun ones that people continue to study. But as far as planetary science, which is my background, we just like to investigate, okay, what can we learn about this floating ice shell? And so we found that it's solid ice with a bit of a liquid layer underneath, and they think that it actually is an ocean. And so looking at Io, they found that the other 4 Galilean moons are similar icy bodies. And what's been fun about these moons, yes, well, you are on Jupiter.
Okay, yes, and we can see 3 of the moons. Estefania, you've got Stellarium. Tell us, which one's the closest one to Jupiter?
Well, let's take a look here. It looks like it's Callisto.
All right, so we've got Callisto's closest, and then we've got Io and
Europa.
Europa.
Aren't they right next to each other?
They are. They're right next to each other. They're buddies.
So that's going to be, oh, it's cold out here. That's
Too cold
the
to
second
see.
dot, right? That second dot that's further away are where both Europa and Io are. So while Heather's talking about them, you can look at them.
And enjoy. That's what's been fun about the Galilean moons, is on these clear nights, you can actually see them. And if you go out on multiple nights, you can see how the position of these moons change over time. And that's actually what Galileo himself did. And that's how he noticed that these moons orbit the planet, and not everything orbits the Earth. So there's your fun fact for learning how the astronomer all of those years ago learned about movements of heavenly bodies. But anyway, back to what I was telling you about with the Galilean moons and learning about, oh, we lost Jupiter. The eyepiece came out. Okay. Oh, are you changing them around?
Yes.
All right. But using the similar techniques that Galileo did all those years ago, they started looking at the movements of the Galilean moons around Jupiter and noticing that the moons, when they lined up, actually displayed very noticeable compression and decompression, and that actually heated the moon's interior up a little bit. And that showed them a lot more about the interior of the moons, and for Europa, one of the first moons in particular, that they learned the most about for the interior, and that's just because of its positioning, Europa and Io. Positioning as well as the size they're able to learn about. So it's one of those fun facts, with the interior being more ocean. And again, with that, if you think of a rubber band, with that pulling, and is what happens when the 4 moons are aligned. You get that gravitational pull as they all orbit around Jupiter. And so Europa sees a lot of what looks like volcanic activity, but it's not solid rock. So it's a very active little moon. All right, so Krista, are we gonna look at Jupiter again?
Yes.
All right.
I'm just about there. Oh yeah, I'm just about there, just about ready to do it. I'm taking off the filter off the eyepiece. So this is my setup, in case you were wondering. I got my cell phone hooked up to a cell phone adapter.
All right.
Eyepiece in. Okay, I'm gonna use a Barlow.
Okay, so a Barlow is where you increase the strength of the eyepiece even more.
Get zoomed in.
Yeah. So since Krista is going to let us see Jupiter with even greater magnification, we can go ahead and talk about Io, which is an even more volcanically active Galilean moon. And it's, in fact, the most volcanically active body in the solar system. And that kind of stumped people as to how such a tiny body could be so extremely volcanically active. And again, that goes into, okay, interruption. Krista just turned on. We've got to see. It's beautiful.
That looks phenomenal.
Look at those 3 moons.
You can see 3 of them.
That's
Look-
exciting.
So, Callisto, right? Callisto's close, and then that middle one actually has the 2. That's the Io Europa, and then Ganymede. Ganymede is a moon that I like to talk about because, do you know why?
All right. Should we do a drum roll? And she's going to let everyone know.
All right, well, put it in the comments why you think it's special. I should have said that before I paused. But okay, Ganymede is special, not because of how it looks, because of its size. Ganymede is bigger than Mercury.
Imagine a moon that is bigger than a planet.
So, why do we call it a moon instead of a planet? Estefania, do you know why?
I mean, I kind of have like, I don't think I do. I have my guesses, but
What's your guess?
well, it orbits a larger body, and it was trapped in its gravitational field.
Yep. So Heather, there are 3 requirements to being a planet. Give us one of them.
One of them, it needs to be on the right plane, along the ecliptic plane, orbiting around that central body. And I remember that one being brought up because the group of us professional astronomers were having fun with it.
Okay, so it's got to be in the plane. Estefania, do you know one?
It has to be able to clear its own path.
Yep, it's got to clear its own path around the sun. It can't have any other large objects in its orbit. Okay, the obvious one that I always forget. It has to orbit the sun. So it's got to orbit the sun. And there's one more. It's got to be big enough to pull its mass into a sphere. So it has to be round-ish.
Yeah, that sphere one is what got Ceres.
And the path one is what got Pluto.
And the
I
orbiting
remember-
the sun one is what got, is why Ganymede is a moon. Because it orbits Jupiter.
On the ecliptic is what got Pluto because it travels at a really high inclination.
Okay, Estefania, go back to Stellarium and zoom out until we can see the 3 planets that are visible tonight. Please.
Sure. And here we go.
Oh, can you change the time?
Yes.
Can you change the time and set it to
Oh, yeah.
now? If you click the play button, one over to the side, yeah, okay, stop. That plays a normal time. If you, it's F3 or F5. Or you can, if you scroll over to the, well, no.
We're blitzing through time as it goes.
Go back, go to the right side of your screen.
Mhm.
All right, the second one from the top is your date and time.
Ah,
Whoa, I said the left side of your screen.
oh, okay, sorry. Here we are.
Date time window, 8/5, okay. So, change the date, please. It's the 17th. And then the time is 21:34. Oh, cool. Can you see Mars in my screen? Oh, it's blurry.
Um,
you set it to the right time yet?
Yep,
Yes.
it's on the right time and date.
Awesome.
Now it's just a matter of,
Zooming out.
yeah.
And you can turn the ground on now too. So hit G, that turns the ground on.
How about I just search for Mars?
And then turn the ground back on too, so we can see what we can actually see in the sky. That'd be great. Oh, yeah, there we go.
There it is. All bright and beautiful.
So, okay, zoom out. I want to see Mars and Jupiter and Saturn.
There they
you
are. All right, wait, I see the telescope view.
Yeah, no. Do you see, so, oh, Estefania, can you turn off the meteor showers? If you go to
Sure.
the bottom, go over to the right, yeah, that. Okay. Now, guys, look at Mars and Jupiter and Saturn. Do you see a pattern?
Mhm.
How are they spread it across the sky? Estefania, what do you think?
Well, it looks like they're all on a certain line,
Yeah. Hey,
kind of linear.
mine have a name? Heather.
That line is the ecliptic.
What does it represent?
The ecliptic is a very helpful, very useful line that astronomers use. Also known as the Great Circle, the ecliptic is the path that the sun as well as the planets travel as they cross the sky as seen from Earth. The ecliptic, it defines the plane of Earth's orbit around the sun. And for those who like to think about the zodiac, the 13 signs of the zodiac all lie along that ecliptic.
Oh, wait. Did you say 13 signs of the zodiac?
Oh no!
Oh, no, I knew there were 13. Plus, why there are 13. And Estefania, do you know the 13th?
Ophiuchus,
Ophiuchus.
or Ophiuchus, or Officius.
You know astronomy! So that means you know the golden rule for your astronomy professor: never ask their sign.
Oh gosh. My favorite is when people are so sure of their sign, and then we actually like go on the date and year of their birthday, and then you have the boundaries, and it's completely different.
Yes, we bring in the ecliptic, the line of the ecliptic, and put the signs, the 13 constellations on it. And so that's your homework, everyone. You now know to go onto Stellarium or a star chart and look up the 13 constellations on the ecliptic and see where the months all lie.
Yep, and you can set the date for your birthday. And to do Stellarium, it's STELLARIUM-web.org. I think it's org. And that'll bring up Stellarium in a web browser, so you don't even have to install anything. And you can just put in your birthday. You can turn on the constellations and look where the sun is and see if it matches with your sign. Okay. Oh, you turned on the ecliptic. Yay. All right. I've got Mars in the telescope. Tell us about Mars, Heather. Oh,
All
and
right.
yeah, you can also go back and forth because I think, Stephanie, you know a lot about some of the missions.
Oh, you're going to tell us about the missions? All right. Well, I'm going to tell very little about this because the missions, I think, is what everyone wants to hear because people are really excited about going to Mars. We've been gearing up to head there. So Mars is the rust planet. Of course, we can see that looking through Krista's telescope and also on Stellarium. Oh, wait, I think Krista's pulling, there it is, all beautiful. You can see the beautiful red color. And it does actually look like that on the Martian surface, the beautiful rust color. And it is the 4th planet. 18 wonderful missions have successfully landed there, and we hope eventually that we will get a manned mission there. The largest dust storms in the solar system are known for that, and including we have among the largest land formations on this rocky body. On Mars, the sun will only appear about half the size, given its great distance. It was named for the Roman god of war, and given the extreme weather conditions on there, it does seem appropriate. That's one of the difficulties we've had for trying to plan missions to there and getting successful missions, because out of nowhere you can go from what appears a beautiful sunny day to a massive storm that will put the Saharan dust storms to shame, and it will just obliterate the ability to see or keep the equipment in safe conditions. So trying to work with Mars can be a bit challenging. What's interesting about Mars is its orbital period is 687 days versus the 364 days here on Earth. Its surface pressure is such that the gravity is only about, was it one, is it, my mind just went blank. It is only, a Stephanie, you remember what it was?
Which part? The diameter of Mars?
For Mars, the Martian gravity.
Oh gosh, the gravity. I always forget what it is.
Well, I know it's 3.7 meters per second squared. I'm trying to remember what it is. It's just under 1 G. So it'll feel, it's, is it 0.8 or 0.9?
I think it's 0.8.
0.8. So it'll...
It's 62% lower than what it is on Earth.
62%. Okay, so I was off. So it's pretty close
So
to the lunar gravity. Yes, Krista.
oh no, go ahead.
Yeah, well, I'm looking forward to Stephanie telling us about missions.
Sure.
And I know everyone else is.
I see two little dots, Stephania. I see two little dots next to Mars, and I wonder if those are the moons.
They most
them
certainly
up.
are.
What?
They most certainly are. There's our Phobos and Deimos, or Desmos.
Deimos?
Deimos. I always get the pronunciation
That's
wrong.
how I pronounce it.
Mm-hmm.
It's all Greek to me.
That is true.
Yay! This is actually my very first time seeing the moons of Mars. Oh,
It's exciting when you get to see them, yes.
yeah, these are cool moons. They are not big and round like the moons of Jupiter. These are small potato-shaped moons. Okay, why do you think they are shaped like potatoes? Put it in the chat.
Little space potatoes.
You could write a book.
Because, wait, Heather?
You could write a book about space potato. Sorry.
I think that, you know, our moon is made of green cheese and Mars has moons made of potatoes and
Well, I thought Ganymede, somebody posed Ganymede is made of green cheese because the name sounded like it.
Io looks like rotten cheese pizza.
It does. It really does.
You could just look at a moon and think dairy.
Well, I look at these
20.
carbs. These moons.
I think of bread.
Hmm.
Okay, back to the potatoes.
I'm on a keto diet, so I can't have bread or potatoes. And let's see.
Back to our moon potatoes and why they
Yes.
look like potatoes versus lovely spheres.
They are captured asteroids, and that's why. Which one's which, Stephania?
What is it?
Which moon is which?
Oh, well, let's see. Phobos is usually closer to Mars, so I would say that's the one that's right next to it, and then Deimos is the one that's kind of further away.
Well, let me stop sharing so that you can show us Stellarium, because that'll show us which one it is which.
Sure, let me just hop right on there,
What?
and here we are. All right, so here we have Mars, Phobos, and Deimos.
Okay.
Ah, Mars.
So that means, oh, let's see. Can you zoom out a bit?
Yep.
Oh, you got to double click on Mars.
Here, how far do you want me to zoom out?
Okay, well, that's probably, so one of the things that we saw in the telescope was a star, and then we probably saw Deimos, maybe.
Mm-hmm.
So those might not have been the moons, they might have been stars instead. Deimos and Phobos are pretty small. Oh, Heather, do you know what they mean? The names mean.
Oh, you know, I have been told yes, but I don't remember.
Well, Phobos, I remember. Phobos, like phobia, fear.
Okay, that's all I think of. I didn't know.
That's terrifying.
I think Deimos is death, but I don't know.
Okay, so they're sticking with that whole God of War theme then?
Yeah.
That
Is
makes
it-
sense.
It must be Greek, though. It doesn't seem like it's Latin. Maybe Deimos is, I don't know.
Well, you guys can look it up in the chat and tell us.
There you go.
What should we look at next? Ooh.
Let's talk about some missions.
Oh, yes. Stephanie, talk about missions.
Oh my gosh. Okay, so I absolutely adore Mars. I love Earth, but I adore Mars. I am a geology major. I love rocks, and that is one big rock that I can talk about all day. I
Keep
think one of
talking.
I love missions. My favorite mission so far is the InSight Discovery mission. So InSight stands for Interior Exploration Using Seismic Investigations. This is a NASA mission in which they sent a single geophysical lander to Mars. It did land in Elysium Planitia. It's kind of like a big, not a mesa, but there's kind of Horse and Grabens on Mars, which is kind of just like one landform where it's higher than the other for simplest version, I guess. But the entire goal of the InSight mission is to kind of address one of the most asked questions in planetary science as far as geology goes, and that is what is going on in the interiors of these other rocky planets. So it has a lot of sophisticated geophysical instruments that kind of detect movements, late formations, or other kind of small processes that would show whether or not Mars is an active planet, or as in like, is it still forming? And InSight's been on there for quite a while. I think it landed sometime in November in 2018, or was it 2019? I can't quite remember, but I think one of my favorite things about this mission is that it actually tells the weather. It has lots of instruments on it, but it does have a large weather instrument where it can kind of sense the temperature and the wind pressure. So I am on mars.nasa.gov, and I have just searched in weather on Mars, and it actually shows me what the weather was yesterday. So days on Mars are not called days. What's up?
So why don't you share that screen?
Oh, sure. Let me try and find it. Mars doesn't have days like we do on Earth. It has these things called sols because Mars has a different rotational period from Earth, as many of the planets do. So let's see here, Mars weather.
How long is a sol on Mars?
A sol is, let's see, everything's taking a while to load.
Do you know, Heather?
Oh. Okay, it's a little Martian year. I know a Martian year is 687 days. A sol is, it's just under 25 hours.
Yeah.
Yeah, like 24 hours and 39 minutes or something like that.
Okay.
Close to 40
All
minutes.
right.
Number. All right,
Here
Sophia.
is the weather report. Can you guys see my screen?
We're still looking at
Please.
Stellarium.
All right, let me just go back here.
I mean, it's a beautiful shot of Mars and then Phobos. So.
Okay. Yeah.
There you go.
Here's what the InSight River looks like, in case anybody was wondering. These are the solar panels that harvest the sun's energies and the photons. Obviously, we don't have any outlets to plug this thing into on Mars, and well, batteries aren't the most reliable sometimes, so not to hate on Duracell. All right. So on October 15th, Sol 671, we had a high of 17 degrees Fahrenheit. Mars does have really extreme temperature ranges. It has a different atmosphere from Earth, so it's not as regulated as our planet. We're a bit spoiled compared to every other planet in the solar system. And then we have a low of negative 141 degrees Fahrenheit. That's pretty intense.
That was yesterday?
Yep, that was yesterday.
Oof.
So if you think it's cold now, imagine Mars when it's hot.
Brr.
Well, I know Mars has the extreme weather changes, summer to winter.
Mm-hmm.
It looks like extreme weather changes night to day.
Oh yeah, we had a wind speed of maximum 42.7 miles per hour, and then a low of 0.6 miles per hour. And on October 15th, it was mainly coming from the west.
That actually is a lot of fun, 'cause it looks like you're just looking up the weather report for home.
Yeah, I mean, hopefully maybe one day one of these viewers, and maybe somebody else, will one day be reporting the weather on Mars.
Yep.
Yeah. All right. What else do we want to see? Or are we done? Or do you have something else you want to talk about?
Well, if we're on to planets, we can continue on to go ahead and look at one last planet. We could always take a look at Neptune. I don't know if
I think
looking
I'm
at-
there, but I don't see anything. I'll share my screen. Oops, no, wrong button. Share screen. Okay. This button. It says something. Okay. Do you see anything? No,
I don't know.
I don't see anything. All right, we're gonna skip Neptune.
Oh, poor little Neptune.
It looks like a star anyway.
He's a big guy. He'll get over it.
He is called a gas giant.
Hmm. Oh, I'll stop my share. Constellations. Do we have a constellation we should talk about? Because we haven't talked about any constellations that are visible. Why don't we go towards the north and talk? We've got a couple people over there. Estefania?
Sure. Let's just go on in there.
Oh, Heather,
Yes,
it's M31 that I'm looking for.
M31.
Thank you.
We've got to look for M31. That's the, oh yes, exciting.
Okay.
All right, so I don't know if we can look for it on Stellarium as well, while Christine's looking for it.
Yeah, I'll go ahead and
Miriam.
All right.
start sharing my screen.
Yep, and show the really cool, I mean, that square. The Great Square. Okay. All right. Okay. That.
All right. So here we are in the north. And what I've done now is that I've turned on the constellation outlines of each of these lovely little stories. And Professor Spites mentioned a square. I don't know how many of you are familiar with your constellations in the chat, but any guesses as to what that square might be? What might we be talking about? It's pretty big and kind of hard to miss once you see it. And here we are. If we look to the northwest, we'll see the Great Square of Pegasus. A constellation is basically a... Huh?
I think
Your,
Hercules.
what?
That one's Hercules. It's going to be in the northeast.
Oh, God.
So, yeah, and if you go, okay, find, it's above Mars.
Okay, there's Cass.
Yeah, Cassiopeia.
There it is. There it is.
Right.
Here we go.
Yeah.
right.
So oh, sorry, Heather.
Oh, no, go ahead.
Sure. So, a quick little thing about constellations is that there actually is an organized system to all of this. The International Astronomical Union recognizes 88 constellations covering the entire northern and southern sky. All of the night sky has been fully out with constellations, borders, images, and of course stories. Different countries have different names, lore, mythology, and even lines for stars. And this is ours, probably the most known. A lot of our constellations are Latin in origin, and they're dating from the Roman Empire. But as time goes on, stories get twisted, sometimes changed, and well, things are a bit different from what they once were.
So what's the square?
This is, well, first off, it's an asteroid, or an asterism, and astronomers and people all like use these things to kind of help us locate bigger things in the sky. Here we have a square, but this isn't the whole constellation. This is Pegasus right here. The square is the body, and here you have two legs. You have the head and the neck. Ancient astronomers are very creative when it came to creating images for these constellations. I don't know if I would have seen a full-on winged horse with this square and these lines sticking out, but they did.
So what's coming off the back?
Oh, we have a little fuzzy dot right here. I don't know if anyone can
Oh,
see
well,
that.
what's that constellation?
This one right here. This,
Andromeda.
yep, and here we have Andromeda. I've seen art where they have another little line right here, but everything's different, so.
Yeah, you can draw the lines however you want. It's just the boundaries.
Mm-hmm.
I think if you hit B, that will turn on the boundaries of the constellations. Yeah. So even the stars that are not connected by the lines, even those are in the constellation. You know, let's say Pegasus, the stars inside the square, or you know, those are still in Pegasus, even though they're not connected by the dots. I mean lines, connected by lines. Okay, so Andromeda. There's a story with Andromeda that's pretty neat. Can you tell us the Andromeda story?
Sure. So, beginning with this little backwards 3 or sometimes W, we have an Ethiopian queen named Cassiopeia. Cassiopeia is married to this constellation right here known as Cepheus. The Greeks often drew, I guess we would call them stick figures, as a square being a torso and sometimes a triangle being a head. Again, very creative. I'll go ahead and turn on the art for storytelling purposes. But you can see that Cassiopeia is sitting in her chair. So I've seen it as a throne. But Cepheus and Cassiopeia have a daughter named Andromeda. And one day, Cassiopeia was just walking along the seashore on the beach, and she was just kind of yelling about how beautiful and magnificent she was at no one. She was just talking to the water and yelling in its direction. And while doing this, sea nymphs, which are kind of like Greek mermaids, overheard this, and well, to them it seemed like this random mortal was screaming at them about how beautiful she is, how she's the most beautiful person in the world. And well, being an immortal being, they just couldn't have that, so they told their father Poseidon, and he got very upset as well because his daughters were told that they were uglier than someone else. And so because of that, he sent this big monster named Cepheus. Cetus. Cepheus is the husband.
Well,
go and terrorize the seashore. And he's down here, kind of a little, here's the body and then the head. And well, frustrated, the king and the queen asked Poseidon what they could do to make all this terrorizing stop. And he said, sacrifice your daughter Andromeda. Andromeda had nothing to do with this ordeal, and it's very, very sad that she took the blame and most of the heat for her parents. And so what they ended up doing was that they chained her to a cliff where she was essentially waiting to be taken away and killed by Cetus, the sea monster, to Poseidon. And while this was all going on, the hero of our story, Perseus, had just finished slaying the Gorgon Medusa. And well, as he was kind of flying on Pegasus, he saw this beautiful statue of a woman and then saw tears coming down. And he quickly realized that this was no statue. In fact, it was a woman, and that woman was Andromeda. And just so overcome by her beauty, he asked her to marry him and asked why she was sad. And when she told him what had happened, he just couldn't bear the love of his life, who he just met 2 seconds ago, to be killed and taken away by a sea monster. So he ended up slaying Cetus, and then, after he did so, asked for her hand in marriage to her parents, Cassiopeia and Cepheus, and then they flew away together and lived happily ever after. The queen, however, did not get such a happy ending. Cassiopeia, for being so vain and for terrorizing the sea nymphs, was thrown into the night sky, upside down on her throne to circle around the northern star, Polaris. So she's forever trapped up there.
She deserves it for treating her daughter that way.
I mean,
I know, that just really, come on. Heartless.
Cepheus never really said anything either this
No,
whole time.
I think they both deserve to be thrown up there like that.
Yeah.
Do you notice he's upside down himself?
Yeah. But with that story comes kind of some other interesting topics. You kind of see here a little fuzzy dot. And this is our celestial neighbor. Heather, I don't know if you want to talk about that.
All right, so we're going on to M31, the Andromeda Galaxy.
Zoom in on it.
All right, so M31 is a fun topic. As you heard, it is a fuzzy. In fact, it is just about the brightest fuzzy you can see with the naked eye. As you see, it's a very large one, and if it were closer to us, it would cover about 6 Earth-Moon diameters in Earth's sky. Yet it's very far away, so it's kind of dim, so we only see it as a small fuzzy. However, Krista's pulling it up with a telescope so we can see it a bit better. Now, here's where it gets really fun. The Andromeda Galaxy is moving towards the Milky Way galaxy at about 110 kilometers per second, or for those who are more comfortable, 70 miles per second. I think I have that correct. So we're set for a collision course in about, calculation-wise, 5 billion years. Now, normally that's the end of the story. However, a publication came out in August that used Hubble Space Telescope data combined with an absorption map ionized gas in Andromeda study. And what that study did was it looked at very distant quasars and it used the light from those very distant quasars as the light passed through Andromeda. And what that did was allowed the scientists to see how Andromeda was moving, but also allowed the scientists to study the halo, to better study the halo of Andromeda Galaxy. Now, everyone is more familiar with the disk of galaxies, and the disk is that visible area. If Stefania, you want to put your cursor over that and really highlight it for everyone to see the disk of the galaxy, and that's where all those visible stars are. But we're getting more and more familiar with the halo of the galaxy, which has very few visible stars, but there's actually a lot of dense matter that we actually can't see of a galaxy. However, doing calculations and observing what we can see lets astronomers know there's a lot there. And then going down into, just as we're starting to touch on the visible portion of the halo, they found the Andromeda Galaxy's halo extends well out to about, 2 million light years beyond the Andromeda galaxy disk. So that's about half the distance of the Milky Way, half the distance to the Milky Way galaxy. Now that's just the halo of Andromeda. The Milky Way has a halo as well, and its halo is equally as large. So in the study of the absorption map of ionized gas in Andromeda, these scientists have found that the halos are starting to touch and interact. So if we look at, in the bare bones of it, the halos touching and interacting, what does that mean? The Milky Way and the Andromeda, yes, they're starting to collide. Now that's just on the halo. So it's really cool, groundbreaking. We're all getting really excited because the galaxies are merging. The disks are still, about 5 years apart, 5 billion years rather, from actual full on, the disks will collide and everything. But we can still all enjoy that. Hey, the halos are touching. This is exciting. And sure enough, as the Andromeda gets closer and closer and closer, we'll be able to, and our future generations will be able to enjoy that this little fuzzy will start to get brighter and brighter, and you have better viewing of it. So this is something really exciting. And keep an eye out for the astronomy news as to how much more we can learn as we observe and study the interaction of the halos. So that's why I was really excited. And Krista said, M31, right? Yes, let's discuss M31. Because August was when they were able to figure out that the two halos started touching and they're interacting. So everyone, congratulations. We are all in groundbreaking astronomical news here.
All right.
Well, that's cool. I didn't know that they were actually colliding currently.
Yes, the halos have indeed, they are touching and interacting. Yep. So that was all exciting. Everyone's who's into looking at that was jumping for joy. And, hey, look what we found out.
Oh gosh, it really I think it's little things like that that really inspire people's curiosity and want to learn more about the universe around us. And for those of you watching, I really encourage you to kind of delve into these things and to not be intimidated by maybe the large scientific words or the math involved, because it really is a beautiful thing. Like even the pictures that we have for this entire program of Stellarium, all of this like knowledge and tools and resources that we can use to study these objects and really understand things outside of our physical world is just phenomenal and exciting and great to be a part of. And I think past astronomers and scientists and early philosophers would just be overjoyed and amazed at how far we've come as far as innovations and tools and knowledge.
And we all get to build on what others have contributed, and our contributions will help future generations. And you never know what you will be able to help someone else with, and that's what's exciting. It's all of us coming together and just seeing what we can learn and work with others. That's what's exciting. So I don't know if Krista was able to get M31 up,
No.
or the sky's not cooperating anymore. The fun of observational. But right next door to M31 in Pegasus is M15. We could always look at, since we've discussed both constellations and had fun with the stories behind those.
Yeah, I'm realigning the telescope. And so why don't, Estefania, you pull up M15, and Heather, you talk about it, and then I'll align it and then find it.
All right, so M15 is a globular cluster.
Is that?
A globular cluster is a grouping of stars that is very tightly bound, and they are orbiting around so tightly. The belief is that they're bound together by each star's gravity. And so for the globular cluster, it's mostly, they're all tightly held in, bound by gravity, giving the cluster its spherical shape, as well as the cluster's high stellar density towards the center of the cluster, as well as you can see in the cluster that there's some stars out towards the edge of it, and as you start to go in, there's a little bit more, but once you get towards that center, it's really, really dense. And that's not because we have a huge, huge star in the center, it's because there's millions of stars all in that center. In fact, with M15, it measures overall about 210 light years across. However, more than half of its density lies within only 10 light years across. So you see this globular cluster, they are really, really compact. All those stars are just really super, super tightly held together. And so M15 is known for being among the oldest objects that we can see, as it's estimated that it's about 12 billion years old. It's also it's also among the brightest that we can see, with an apparent brightness of 6.2 magnitudes. Or not apparent brightness, it has a brightness of 6.2. Its apparent brightness is compared to the sun 33,600 times brighter. I'm going to get my numbers right. It's 360,000 times brighter than our sun. That's how bright its apparent brightness is. It's M15 has been a globular cluster that a lot of astronomers have enjoyed studying. What contributes to such an extremely bright apparent brightness, as you can see, is those millions and millions of stars just all packed in together there. So how far away is this? It's that you do have to have a telescope to see it if it's so extremely bright. Well, it's 33,600 light years away. So even though it's extremely bright, we still have to use a telescope, but it's still absolutely gorgeous to see if you can go outside with a good telescope or pull it up in stellarium. As you can see, it's just gorgeous. You can see all the different colored stars in there. Just globular clusters are a lot of fun.
Oh, absolutely. I mean, it's just so, that is gorgeous to look at. And I think this isn't a very big piece of sky, is it, Heather?
It's measured in light years. That's how small it is. It's only 210 light years.
Oh, wow.
Across the, and that's for the entire cluster. That includes for the farther out stars that are really loosely bound in there. The really bright center of it, where it's all super compact, is only 10 light years. Globular clusters are known for being just dense with those stars. Yep, so they don't take up much room, so to speak.
Yeah, I think when people see these images, they think that it's like a very large piece of space that they're looking at. And really a lot of times it's just that space is dense and absolutely filled with millions and billions of objects in such a small area, and we're so limited by our atmosphere and by light pollution and other things that block us out, sometimes clouds. But yeah, it's definitely something just great and fun to think about.
Well, what's interesting about globular clusters is you compare them to open clusters like NGC 752, and that's another one we can look at. Open clusters can take up close to the same amount of room, but they only have hundreds of stars. And you can compare the two when they're together. They're not going to be actually together. You can compare images of the two, is how I should say it. And it's amazing to look at because you have this brilliant globular cluster. You compare the estimated ages and then look at that open cluster, and just those globular clusters, super dense, super bright, old stars, and you get that open cluster. Loosely bound stars, not as many, younger stars. In fact, we can take a look if you want to go to NGC 752.
Sure.
And that will show us an open cluster, and then everyone can see the two.
NGC?
NGC 752.
All right. Should I go in more?
If you can go in just a little bit. Yeah, no, because that's way too far in. It's an open cluster. So come back out. Yep.
Like this.
Mm-hmm.
Yeah, these are definitely.
What it is it takes up about the same amount of space, but the stars are loosely bound together. And we went from millions of stars, tightly bound, by the star's mutual gravity to an open cluster has hundreds of stars. And they're loosely bound, they kind of orbit around the same disk. And you really see the difference here.
Oh
In fact,
yeah,
if you
definitely.
zoom way out, you'll see, oh, okay, those are associated.
Yeah.
Not quite as brilliant to look at, but you can see, okay, that is a grouping of stars. Yeah, but it shows you a good comparison between a globular cluster, like in M15, and then you have these open clusters. And you can see the difference in the coloring of these stars. They're not as old.
Oh yeah, definitely. They're definitely lighter. We had a lot of blue and red in the last one.
Mm-hmm. And we're not seeing the red here.
I think we have one,
Yeah, you have.
two. Essentially, we could count them, and we really can't count how many are in the last one. And it closed.
Definitely much younger here. And in fact, for this guy, the estimated age is about 2 billion years. But now, for this open cluster, it is much closer to Earth. So this one is a good fuzzy to look at in the sky. And you can actually see it with the naked eye. So it's, let me see, its apparent magnitude is about a 5.5. So if you wanted to head outside, and in fact, this NGC 752 is perfect to view October through December. So if you want to head outside to a dark sky, you can actually head out and view.
Yeah, I know that there's different types of telescopes, each with a different range and magnification. What would be a good telescope to use for this? Do you know?
Low power. You don't need a really strong power if you just want to do some backyard observing. For this, you could do an 80 millimeter.
What?
3.1. What'd you say? I couldn't understand that. I'm sorry. You could even use binoculars. I would get 1050 or 750 binoculars, and those would be really good.
Yeah, I think people always want to get into stargazing with telescopes or binoculars and think they have to buy the most expensive, grandest things. But there's a lot of these things you can just see with the very basic ones, sometimes with the naked eye. The Pleiades is a good example of that. Just you can easily count the stars, and get a telescope, you can just see it just as well.
Mm-hmm. Yeah, if you go and get yourself just a decent pair of binoculars and a dark sky, you can have a lot of fun. Pleiades, this open cluster would be great places to start. Look for the constellations. You did a great introduction to the constellations. Another great one to enjoy seeing with the naked eye would be Mizar and Alcor. Mizar and Alcor. In fact, if you want to go to those.
I didn't spell that right, did I?
Mizar would be Mizar. In fact, you could just, Mizar by itself would get you right there.
All right.
Yeah.
Ooh, a double star.
Zoom on out so everyone can see where it is located.
Okay, I'm going to take off the ground so we can see the rest of it.
And do you want to tell everyone the story of the constellation?
Sure. So, turning on the art, we have some bears. Zoom out some more to see the little one. But this right here is Ursa Major. And it's the Big Dipper. I talked earlier about asterisms and just why we use them and have them. So here we have the little spoon or the ladle, and then we have the handle. But this is actually a full constellation. So Ursa Major means big bear. Ursa Minor is near. It's called the little bear. Right up here. So there's another story behind this, and essentially Zeus was very he was kind of a player, much to his wife's dismay, Hera, and he fell in love with this mortal woman, and Hera found out. Well, he just didn't want to be in trouble with her, and so to avoid he essentially got rid of the proof, and he turned his human lover into a bear. Little did he know that he actually had a son with him, that would make him a demigod, a human and a god. And while Zeus's human lover roamed the earth as a bear, and their son grew up to be a great hunter. And one day, as he was hunting in the forest, he came upon a bear. This bear turned out to be none other than his mother. And for a moment, she forgot that she was a bear. And when she saw her son, she was just so excited and just, she had my son, and just ran right up to him as a bear. Zeus, seeing this all go down, felt really bad for what he had done and came up with another great idea, as he has many, and turned his son into a bear right before he could shoot his bow and arrow. And then he grabbed both of them by their tails and flung them up into the night sky, where they could be safe from harm from Hera. And that's why their tails are so long. These parts right here are the tails. Turning the art back on, and there you have it. The fun thing about constellations is that they're really up for interpretation. So personally, I think it looks more like a raccoon. I've heard people say beaver.
If you look at the art, I like to look at it backwards. And I think the tail is the head of a horse. So it's a horse with the tail, the head goes from Mizar out, and then the neck, and then you have the body and the back legs. Well, it's getting late. I'm going to shut it down. So, thank you all for joining us tonight. And you can watch the dome close.
All right.
Oh, okay.
Shall I turn off the red lights and turn on white lights? Why not? Then you can see what we're doing.
For those of you who may not know, often we use red light because it doesn't take away our night vision when doing things. So that's why she had the red light on the entire time in the observatory.
So that's a tip you guys can use when you go outside to observe with the naked eye or telescope binoculars. You can get a red flashlight, and as you adjust to the nighttime, you can use your red flashlight, and that'll keep your eyes adjusted to the dark. All right, get ready. There goes the dome.
Okay.
The roof rolls. It's basically a shed, and the roof rolls back off the end, and then pulls back up forward. There we go.
I see you're repping the planetarium beanie.
All right.
Oh yeah, yeah. And this is my Glippen mask, Great Lakes Planetarium Association. Aviation.
Cool.
I just had a planetarium conference and actually presented our live star shows.
All right. Well, I wore a globular cluster.
Oh,
Figured I'd wear it.
and I got a NASA Goddard shirt and the man. I got the man. And I
There
got
you go. I've got there you go. I've got my moonlight. Let me see.
Cool. Yeah, I've been meaning to get one of those. You can't see it, but I have Europa on my laptop as a sticker.
All right.
Um,
I like
and I have,
I like this light because it gives you a blood mood option. I don't know if you can tell.
wow. Yeah, kind of.
The fun of being astronomer is you get to enjoy all these quirky gifts.
Gosh, it's a great hobby. It's a great hobby. It really is. I wouldn't trade it for anything.
Don't worry, I've got plenty more. Almost closed. Oh, the sad side at the end of the night or morning, depending on what you're working on. Yeah. Although what's fun is when you're on your first observing run and they send you out to the telescope dome and it's all dark in there and it's just, and you get to be there the first time they open the dome shutters and it's just, oh.
I think we could close off on some like final pieces of advice for stargazing or getting started. Sorry if you'd like to go first. I think one of the hardest lessons I ever learned was be prepared.
Yes.
I don't care what the weather says.
No.
If you're going to be observing past August, bring gloves. I did not bring gloves and had to set up a telescope in 5-degree weather.
I think your advice about don't care what the weather says, you're going to be out there for hours. Just because you can stand outside, it's not cold. You're going to be out there for hours. Dress warm. Dress in
Extra socks.
layers. The layers will help. Mm-hmm.
Yeah, I grabbed my winter jacket for the first time for tonight.
Yes. Yep.
Okay, that telescope is shut down. No, I got one more telescope to shut down. Down here, I got a bunch of telescopes in here.
And then this one isn't an essential advice. This is more of to help you really appreciate what you're looking at. And it was what someone did for me that helped. When you're outside observing, he picked the Pleiades, which is something you had mentioned earlier. You go out there, look at the Pleiades as soon as you walk out and count the stars. After 20 minutes, recount the stars and notice how many more you can see. Once you've been out there for an hour, recount the stars. How many more do you see? It's amazing as your eyes acclimate to the dark, just how much more of that sky opens up to you. And I was able to be out there for 3 hours, no turning on any lights except a red light. After 2 hours, he had me recount the stars on the Pleiades, naked eye, no binoculars, no telescope. I could see more than 7 stars, which Pleiades is the 7 sisters. I could see more than 7 stars. By the 3-hour mark, I was able to count over 30 stars. It was amazing just how much you can see if you're in the dark and you let your eyes acclimate. It's a phenomenal experience. Really what's blocking so much of our ability to see the sky is light.
Mm-hmm.
It was beautiful.
Wow.
So,
Well, thank you all for coming out tonight. Thank you, Heather and Stephania. And I'm signing off and we'll see you next month.
All right. Thank you. This was
Bye.
fun. Bye.
Thanks.
Bye.